broken it out into 4 different categories, from schematic to waveform viewer to symbol editor to kind of the user interface. And I think realistically within an hour I'm going to get through those first 3 topics and first three sections, and we're just going to kind of launch into it. It is it's an a la carte webinar. It's not really following a very die-hard theme, so I'll just kind of tell you we might be jumping around a little bit here. So first item is copy hierarchy, and I don't know how many folks are using copy hierarchy, but this is a really useful tool to archive a schematic design. So if you have a top-level test bench schematic, it uses a number of schematic components to define, say, a controller or a power system, then you can make an archive copy of that using file copy hierarchy. And when you run that menu, you will be prompted to get a new directory to put these files into. And SIMPLIS basically burns down through the entire hierarchy, figures out which blocks are used and which blocks aren't, and it only copies the blocks that are used. So you can have multiple unused blocks in the directory that will not get copied out. And the only kind of 2 key points here is that those schematic paths have to be relative paths. So when we place schematic components, we place them relative path, and that the hierarchy is something like a top-level schematic with your schematic components in that directory or in a subdirectory. So for example, on the left-hand side of the screen, I have buck converter, and then modeling blocks is a subdirectory that has all of my schematic components in it. So just to kind of give you a flavor of this, here's my top-level test bench. I can descend into this hierarchical block with Control-E, and I can descend again into another block with Control-E, and then Control-U will bring me up to, twice will bring me back up to the top level. If I want to make a copy of this to send to a colleague, for example, or to archive at a certain state in the design, I would simply go File, Copy Hierarchy. And you'll get a hint box that pops up saying, you know, hey, you got to use relative paths, and the path location requirement has to be met as well. So I'll just make a new folder here. I'll call it temp. And I'll select the temp folder. And the next window that pops up says, we're going to copy all of these blocks. And so the blocks being copied are from buck converter, the top-level schematic, throughout all of the hierarchy, so that the program automatically detects which blocks are used. And when you click OK on that, you'll see temp changed over here in my file view, and this has just the buck converter and its associated modeling blocks. So that kind of gives you a flavor. That's very, very useful for archiving designs. So the next one that I think is really useful, a little tip and trick, is you can edit multiple fixed probes on the schematic at the same time. And you might ask, why would you want to do that? Well, that will allow you to put the curves generated by those probes onto the same graph and grid or axis quite easily. And so the way you would do that is you select multiple probes on the symbol, and then you just double-click on one of them, just as if you're just double-clicking on it as if you've got one selected. And you will not be able to change the label of the curve, because that would make all of the probes identical. We don't want to do that exactly. And then you can edit the probe properties, and we'll leave the name or the curve label intact. So then we'll basically make these probes all identical. So they'll have the same graph name, the same axis name, and as a result, these probes will output curves to the same graph and axis or grid. So I can actually just kind of show you kind of as a flavor here, this buck converter, if I run this schematic, I have high side gate and low side gate, HG and LG. They're out here on digital axes right now. But what if I want to move both of those to a common axis by themselves, or common grid? I can select both of them, and I'm doing that just with the standard Windows method. You select one, and then you press and hold Control key. Select the next one. You can either double-click or press F7 at this stage. And you'll notice this probe dialog looks just like a standard probe dialog, with the exception that the curve label is disabled or grayed out. So it's currently saying these probes are on a digital axis. So let's choose a new grid, and we'll give it a name so that we know those will come out to a new grid all by themselves. We'll talk a little bit more about organizing curves later in the webinar. And then let's give it a display order. So I want to push these new curves out onto a grid above vout, and because I've prepared this, I know this has a sort order of capital A in the alphabet, and 0 comes before A, so that means we're going to promote the new grid above vout. So this is basically just this arbitrary string just does an alphabetic sort. And if I click OK on this, and before we go further, let me just show you. If you double click on LG, you'll see it has still the same curve label because we didn't change it. It has used a separate grid. It has the axis name and the display order. And we should see the same effect here on HG. So in doing so, I've been able to, if I run the simulation, we'll output the new LG and HG curves to a separate grid. It's coming above vout. The old ones are still here just because we've got persistence, so we're keeping the old versions of those curves. So that's a really handy way when you're going to go organize your curves, how you want your curves to come out on the graph viewer, and I'll talk about that in greater detail in the Waveform Viewer section. But being able to select probes that you want to come out to a common grid or graph or ASCII is a really handy way of doing it, and it allows you to do a lot of work with a lot fewer clicks. So the second item here is highlighting and unhighlighting nets. Okay, so we had a couple of questions come in. I'll answer that last one, Matt. Maybe you can grab the other one. You cannot delete the lowest grid. This was the question. This is our default grid. It's always here. If you don't put a probe out or curve out on that grid, it will still persist. So I'll just say that up front. I'll talk about that more in the Waveform Viewer section. So let's see, I think I can probably just close the Waveform Viewer. We're not going to be using that next. So highlighting and unhighlighting nets, very, very useful for debugging designs. And I've used this for years and years. And just recently in version 8, we assigned keyboard shortcuts to it. So the letter number key 9 above the I key on the regular keyboard is will highlight a net, and then you see your mouse turns into a probe, and we'll highlight that. And let's press 9 again. We'll highlight the switch node, for example. And just to show you how this works, if you descend into the hierarchy, we've highlighted throughout the hierarchy. And as a result, we've got the switch node is highlighted here in light blue. Now, I made a comment in here about air wiring. So air wiring, so connecting nets or parts on a schematic, but using terminals or module ports to do it. So you'll notice boot, which I selected and should be pink. This is the boot pin here. You notice that's not selected or highlighted inside of the hierarchy. And the reason why, if you zoom in, you'll see it's just a direct connection with no wire. So if I add wire to that, so I've got a piece of wire I can select, and I'll just ascend back up to the top, and I'll start all over again. So I'm going to press 8. 8 unhighlights all nets, and then I'm going to press 9. I'm going to highlight boot, press 9 again, and I'm going to highlight switch. If I now descend into the hierarchy, you'll see boot is highlighted. So we get a number of schematics, that we're trying to debug for tech support where there's 0 wire length in between a terminal or a module port and a symbol pin. It is almost impossible to debug how those are wired together. So just the suggestion is, when you're building your schematics, leave some wire. It'll make the hierarchy highlighting work much better. So again, I can press 8. That'll unhighlight everything. So the next part is about selecting wires and not symbols. And so there was a question that came in, couldn't terminals also be highlighted along with the wires? You know, yeah, in theory they could be. That's not how the program works today. Just say that up front. So selecting wires and not symbols. So we have a special mode, a selection mode. When you press and hold down the Shift key, and then you click with the mouse button, we will target wires and not symbols. And this is really useful. So there's times when you'll get into a situation where you might want to put a current probe, for example, and you want to put that current probe in series with a wire. So I could, for example, copy and paste a current probe, and I'm just going to go ahead and rotate it so that I have the direction that I'm thinking it's going to be. You can just place this on a wire. Now obviously the wire there is shorting out your current probe. So normally if you went to go try to select that wire, it's pretty tricky. So you've got the symbol wants to get selected and the wire gets selected. So instead, if you press and hold the Shift key and drag a mouse box, we will select just the wires. And now you can press delete and you would have what you're after. The other place where that comes in handy is, you know, there's times when you will accidentally put a wire across 2 pins on a symbol. And again, you've got the same problem. Almost impossible to highlight that wire. Here I got lucky. So you can just do a Shift and drag a box and highlight that wire, and then, you know, if I didn't grab the symbol, you can move the wire. So it kind of gives you an idea of that selection mode. Now there's a corollary, which is we run into this problem with very short wires. And the problem is whenever you get close to a whenever you get close to a terminal symbol pin, you'll notice the program enters into a wiring mode and the cursor changes. So that Shift key, as it turns out, also disables that. So here I'm normal mode. So mouse moving towards a pin turns into auto wiring. Now you can't see my keyboard, but I'm holding down the Shift key now and doing the exact same thing. You notice no auto wiring. So what that means is, for example, when you have a really short wire and you try and select it, you know, you can't select it because as soon as you get within half of a grid square of it, we think you want a wire to it. So in this case, sure, we could just do it with a box select, but sometimes this wire is, you know, hidden deep inside of some other symbol mess. So just press and hold the Shift key. You can get right on top of the wire and you can select it, and then press delete to delete it. So it's kind of a neat little trick to select just wires. You'll see it works not just on short wires but also on longer wires. Pressing and holding the Shift key to select just wires and not symbols, and also not route to them. So that's kind of the nuts and bolts of that particular item. So I think there's a question that came in. Let me go back to a schematic, and it was about whether or not we need a grid. And believe me, you need a grid. So, you know, is it possible to avoid auto-selecting on the grid entirely, or must there be an auto-select grid? We really do need a grid, or else we wouldn't know where symbols are located. They kind of need to be located on an integer location, aka a grid. Okay, a couple other questions came in. Looks like a good time to answer those. So the first one is sometimes after copying a schematic, the copied part is off grid. Can I readjust that somehow? I guess I've never seen that before. You might be thinking about somewhere in the symbol editor. That's where I've seen that kind of behavior before. And when you copy the graphical parts of a symbol from one symbol to another, and it depends on where you were on the previous grid. So I don't know what to say about that, but I know that person knows me, so they can pop me a quick email with something on that, so we can maybe move on. Okay, so let's see, any other questions before we move on to the 6th item here? Okay, so I'm going to go ahead and move on, talking about schematic components. So schematic components are often a source of some confusion. And let me just pause and give the standard speech, which is they're really containers. Imagine a box as a container that holds two little separate parts in this box. So you put a divider right down the middle. One side of the box always holds a symbol, and the other side of the box always holds a schematic. What's really neat about this container concept is now we have a really simple way for one file to hold not only the electrical definition, which is the schematic, but also the graphical definition and the pins, which is, the symbol. And so most people probably don't realize you can save a symbol from one schematic component to another. And there's some good reasons for doing that. And I'll kind of show you one of them. The other thing you can do is you can save a symbol from one of the global symbol libraries into your schematic component, which will help you save you doing some redrawing. And I'll show you that one in the symbol editor part of the program today. And then the third item I just want to make mention is when you are on a schematic and you use the file save schematic as, it only saves the schematic part of the container. It doesn't save the symbol part, whereas file save special saves both the schematic and the symbol. So before I get to key points, I think maybe a little tangible example would be in order. So suppose I descend into this hierarchy component. So this is a schematic component. And if I did, those of you who are a little newer to the program, hierarchy, open create symbol for schematic opens the symbol, or the shortcut key S. And you'll see I've got my symbol, which clearly has been worked on. It's got nice graphical lines and so on and so forth. So I'll go ahead and close that. So what I think I'll do for a demonstration is I'll use that file save schematic as, and I'll just make a temp version of this. And now I've got this, and if I run that same menu, hierarchy, open create symbol for schematic, notice you get a different symbol. So this is the auto-created symbol. This is the symbol that, as we like to say internally, only a mother could love. So here's our symbol, and the problem is if we save this symbol into our schematic component, we're going to have problems when we go to use it, because back here on the buck converter, none of those pins are going to line up. So let me go to that symbol, and I'm going to close that without saving it. So as I mentioned, we can copy symbols from one schematic component to another. So what I'm going to do is I'm just going to, so that I remember what I'm doing, I'm going to go ahead and close everything except for just the buck converter. And I'm going to descend into this hierarchical block. And in here, I'm going to do hierarchy, open create symbol. Instead of saving this back to drive logic and drivers hierarchy, I'm going to save this into my temp file. So I'm going to do file, save symbol. Now, it gives you a couple of options. So we have the library file, the component file, or the schematic file. So this is kind of like being saved into memory. But I know I have that other schematic component, and it's _temp. And I'll just go ahead and click OK on that. And I've just saved that symbol into the temp version. And just so that we're all clear, this is not the temp version. But what I can do is I can place that just for a test using relative path. And what do you know? There's that symbol. and it's identical. And if I think it's Shift S in here will open that symbol, and you'll notice it's pretty much a clone. So it's kind of handy. I know in the past when I've been using SIMPLIS in industry, I would sometimes, for example, I would be here. I would say, okay, I'm going to make an experiment. I'm going to save this file off, and I didn't save it with the symbol, and then I made a number of changes to the schematic. Well, now what do? Right? You need the symbol back. So that little trick shows you how to push a symbol from one schematic component to another, which is kind of handy. Okay, don't see any other questions coming in. So next webinar in October is going to be on piecewise linear devices, in particular resistors, inductors, capacitors. It'll be a really interesting webinar. We've been wanting to do a piecewise linear webinar for quite a while. And back when the training course just got started, I thought, well, it'd be nice to be able to just select a resistor and look at its piecewise linear definition on a graph. We have that capability built into version 8, and I'll just kind of show you using, let's use the capacitor example first. And this is an example out of the training class, the first module. If you select a capacitor, piecewise linear capacitor, there's this option almost down at the very, very bottom here. And when you run that menu, you'll see this is a nonlinear capacitor. It's representing a pretty much a junction capacitance. And so we define piecewise linear capacitors on the charge vertical versus voltage horizontal plane. And so the slope of each of these segments is capacitance. So in addition to showing you the charge versus voltage, in the command shell we output what the capacitance is for each of these segments. And when you do that for an inductor, you'll obviously get the inductance of each segment and the resistance of each segment. So if you're ever working on piecewise linear devices, and sometimes you're wondering, why isn't this working right? This is a great little debug tool that allows you to look at what the definition actually is on a model. And the other little debug tool we've got is viewing ASCII models. Go ahead and I'll close the Waveform Viewer. So for those of you who are a little newer to the program, we've got models that are built in to the program, and we got models which you create as schematic components or you create as ASCII models. Those ASCII models can get installed into the program. Obviously, we've got a number built in, and you can call them with a symbol. So on the schematic, whenever you have a model for an ASCII component, so for example, this multi-level inductor or multi-level capacitor, you can right-click on that symbol. Zoom in there a little bit. You can right-click and run View Model. And this will open a text file with the actual model definition for that subcircuit. Now, just to say, this text file is a temporary file, so if you edit this, you don't have to worry about breaking something. You can use this to start a new model, or if you're just curious how we implemented something, it's all here in plain text. So most of our models that are built in are in plain text. So that kind of wraps up the schematic. Let me just turn it back to the audience, see if anyone has any questions they'd like to ask before we move on to symbol editor or waveform viewer stuff. Okay. I don't see anything come in, so I'm going to go ahead and forge onward here. So we get a lot of questions in the waveform editor, waveform viewer rather, of how to export and import data. So I've got data from, I don't know, a data sheet curve, and you want to plot that in the waveform viewer. Or quite often folks want to take data from the waveform viewer and push it into a report, and so they're going to want to copy that out. So we have really simple ways to import and export data, and they're on the Edit menu for the graph viewer, and there's Copy ASCII data and Paste ASCII data. And by ASCII we mean basically column data. It's pretty straightforward in the sense that it's kind of white space delimited. copying data out of Excel, for example, works just fine. So I can go ahead and get started here. Let's just get a waveform back up. So I'm going to press F9. I'll make a comment that the next item in our presentation will show you how to do that even faster. But suppose I got this switch node, right? And I really want to examine that. So you can first click on SW and do edit, copy ASCII data. Now that data is on the clipboard. And what you do with it is up to you, but you can, open Excel, and of course that's opening in some strange way. Let me just bring that over onto my main screen here. So now I've got that data on the clipboard, and I can just paste it, Control V. So I've got a time and a voltage column, and all of the data points are here. Now additionally, you can select a bunch of data out of Excel, and here I'm going to do Control C and go back to the Waveform Viewer. Let's see, to make things clear, let me make a new sheet. So you can do that with the F10 key. F10 will generate a new sheet. And now I can just go Edit and paste. And here's the switch node brought back in. The other item I think is kind of a cool tip and trick. I'm going to unselect those guys, and I'll just kind of show you something here. Control C and Control V work inside of the Waveform Viewer. So if you have a waveform selected, say IL, this current waveform, you can press Control V to copy it, and then when you come over to a new sheet, you can paste it. That's a handy way to move waveforms around on the Waveform Viewer. Now here we place the waveform on the lower default grid, which, as I kind of mentioned earlier, is always there. We have a new ASCII, vertical ASCII, IL, and amps, and that's because the Waveform Viewer doesn't like to mix volts and amps on the same ASCII, so it created a new ASCII. You could just as well have created a new grid, and I think I still have that definition, so I can just paste it onto a new grid. There's a question that came in: is there some way to transfer ASCII data from a piecewise linear voltage or current source? Not quite sure if the question is to it or from it, but I know you can do to it. Okay, good, good. Yes, you can. So this is not probably the best example because we're just grabbing whatever random data, but say I copied data here from Excel. All right, so you've got a spreadsheet you use to maybe define a device. And if I go to the program, let me just start a new sheet, and I'll find a piecewise linear device, say a resistor. When you edit this, there is a paste button on this dialog. And when you press paste, you'll see that's the data that I just had selected in Excel. So that's how you would copy data from Excel to a device. Okay. Okay. So there was a question that came in: how would we import a scope waveform into the waveform window? Just like we were just showing. So you would have that data in Excel, for example. You would select the right cells, you would copy it, and then go to the Waveform Viewer and edit, paste ASCII data. Okay. So good questions. Any others that are okay? I don't see any others coming in. So let me show you something that I think is very clever. I think you'll like. Is we have a new feature. I think it came out in 8 or thereabouts, which we call ReplayTraces. So ReplayTraces is a primitive command. What does that mean? Well, it doesn't have a menu. It doesn't have a shortcut key, although at the end of the presentation I'll show you how to assign one. So this primitive command, it basically says, all right, go back to the data group that was recently run, find all of the fixed probes that were defined when that data group was generated, so after you ran a simulation, and replot them. So in the last example, I said, all right, well, we're going to rerun this so that we get the waveform viewer back up. But I can actually do that much more efficiently by using this ReplayTraces command. And you would enter that. It's not case sensitive, so we can just do it all lowercase. The only thing it's very sensitive to is spelling. So if I press, if I do this, ReplayTraces, you can either click OK or press Enter. And you'll see the waveforms are regenerated just as if I had run the simulation. The question came in, does SIMPLIS always convert from scientific notation to engineering notation? As far as I know, the answer there would be yes. Okay, so that kind of gives you an idea. ReplayTrace is very useful when you've got something like, you know, a simulation that took minutes to run and you accidentally messed up the graphs and you just want to get them back again. You can always just close the waveform viewer. Now I have this in my command history, so I can just grab it from here. And it'll regenerate all those curves, which is pretty handy. Maybe I'll just make mention, when we were running through this yesterday, I did make mention when I was describing this that it goes to the last data group. So if you look at your data groups, which is, sorry, I went a little too fast there. Sorry about that, guys. Simulator, manage data groups. So we can only have one current data group in memory at one time. Now we have multiple data groups in memory right now, but only one of them is current. So when you do ReplayTraces, it's going to automatically grab the current data group. Why is this important? Well, if you ran a POP and then an AC analysis, that's two data groups. We ran them in that order, POP, then AC. So after that simulation, AC is the current data group. You might want to go replot the POP waveforms. Then you would have to come here, Simulator, Manage Data Groups, and select the POP waveforms to be current, and then run ReplayTraces. I'll let you know that was one of the things we ran into yesterday. So I think it's probably worth spending a little bit of time talking about organizing curves and graphs. I know from the attendee list we have several people that are very experienced, but also several people that are newer to the program. So SIMPLIS uses a very simple, very simple system, but it's also maybe not obvious. Basically, we try to organize where a curve is going to come out on the waveform viewer by its graph name, and then its axis name, and then its axis or axis type, and then its axis name. So it's kind of three levels, if you will. So it's kind of like, you know, first we need to get in the neighborhood. So we say, well, you know, what town do you live in? That's your graph name. So that gets us close. Each graph name gets a new tab. The axis type determines where we're going to output this curve to. And there's four options. Three are listed here. Auto select is the bottommost grid, and it always exists whether there's a curve on it or not. Use separate y-axis is going to add a new axis to that bottom grid. And then use separate grid is going to add a grid, or people think of them as axes, but we think of them as grids, above the bottommost grid. So then that, you know, the next, you know, kind of conflict that comes is, all right, you have two curves that say use a separate grid, but I want to put them on the same grid. I don't want it on the lowest grid, but I want them on their own grid together, like I did with the HG and LG curves earlier. So in that case, we use the axis name as the alias for that grid. And axis name, we just basically do a simple string match, two curves, two probes, which are defined to use separate grid with the same axis name. They go out to the same axis. And I think I showed earlier the display order is the string, which is basically just an ASCII sort order. So I'll just briefly pop open a dialog again so we can see that. So the first thing we have is use separate graph. And if we don't have a graph name, we just choose a default. and all your curves will come out to that. I think that's what we have this circuit set up for. And then in this case, we're going to use a separate grid. It gets a name so that other curves can go on that grid as well. In this case, the LG curve. And then we sort our new grids from top to bottom on the waveform viewer by a string. This is the display order string. So that's kind of a helpful way. This is also described in the SIMPLIS tutorial if you're looking for maybe a little lengthier discussion. That's called out there. Okay, done with the waveform viewer. Any other questions before we move on to symbol editor? And could you please show again how to plot the data points for a piecewise linear device? Certainly. If you select any piecewise linear resistor, capacitor, or inductor, you can right-click and plot piecewise linear points for R, L, and C. So on the display order discussion, here's a probe that's as good as any. The question is, string number means 1 is on top of 0 or is 3 on top of 2? No, it's ASCII sort. So 0 comes before 1, which comes before 2, and comes before 3. Okay, so then there was a question about naming of the tabs for separate graphs. I think what's being asked there, and I'm not entirely sure, is does the graph name come out on the tab title? And that's something we were working on for 8.1. And we're actually working on a new waveform viewer or an updated waveform viewer for 8.1 as well. But if I've got that question wrong, please kick in another one. The folks who asked that question. Okay, good enough. Anything else on the waveform viewer before we move on? I don't see anything coming in. Okay, so we'll go back to. So let's talk about the symbol editor a little bit and some tips and tricks. So I think, as I mentioned earlier, symbols are defined, saved into either a library file, which in this case is a misspelled library file, a schematic component file, or to our current schematic file, basically memory. What is, sorry, there's one other question that came in here that I think I probably ought to answer before we move on. How do we have the waveform viewer come up so it plots to an undocked, I think an undocked waveform viewer? So that's actually defined in our general options. So the gear icon on the top, and now I've got to think about where we put it in the options. Right, here we are. So this graph placement, so there's a gear icon on the top. This is also File Options General. This is where all the general SIMPLIS options are input. On the third tab over, Graph Probe and Data Analysis. This is exactly what you're looking for, I think. New window will pop it open in a new window. Split does the split screen like what I've got. Overlay would put it right on top of the schematic, not so useful. Okay, that person just said, yep, that makes sense. All right, so symbols, library file, schematic component file, schematic file. So there are times when you might be working on a you're actually working on a schematic, and you say, well, you know, geez, I don't want to start a new symbol from scratch. I just want to basically say, well, I want to go get a symbol from the library. I want to use parts of a symbol from a library. So I've got a little example here. I'll show you. I started a custom source. So this is a DC source. I just started it off simple enough with a resistance. It's got a 5-volt internal source voltage. Now, if I just pressed S, that would open the symbol for the schematic. Currently, I don't have a symbol, so we get a default symbol. And again, it's a functional symbol. It's nothing more. But what if I wanted to instead, I wanted to take this symbol for a DC voltage source and put it into this schematic component file. Turns out you can do that by first editing this symbol. Okay, so now I'm looking at the DC source symbol. So this is one of our built-in library symbols. If you go to save this, you can save it into a library file if you're going to make changes to it, or you can save it into a schematic component file. And here we can go to our custom source schematic component and click OK. And now you notice it says this is the component, C webinar custom source. This is the symbol for it. So that's already saved. And close that. Now I'm back at the custom source schematic component. Just for clarity, show you what I'm doing. Open create symbol for schematic. Well, now it's this DC source symbol. So that's pretty clever, and you might think, well, that's great, but you really have to know some nuts and bolts of this before you can really go any further. So symbols define the netlist instantiation, what goes into the netlist. So I can just tell you up front, V is a voltage source. We don't want to instantiate a voltage source. We want to instead instantiate a subcircuit model. So that's an X. So you'd want to change that to an X. And I'll go ahead and save that. And again here I'm saving it back to the component file. Now there's more work to be done here. You're probably going to add parameters and a few other things. But just to kind of show you that we can make something functional, I've got a test schematic. Again, this is in the archive of files for the webinar. We'll place this custom source, and it's got a symbol, right? We created that. I can press Control E to descend. I can press Control U to ascend. So it has a 1 milliohm source resistance. I've got a 1 milliohm resistor loading it. I'm expecting to see 2.5 volts on the output, and that's exactly what we get. So instead of having to draw these lines, right, laboriously, you can go and get these symbols out of the symbol library, save them into your schematic component. It's kind of a neat trick. Got about 14 minutes left. Any other questions on the symbol editor before we move on to some user interface topics? Okay. So user interface. What most people don't realize is the user interface for SIMPLIS, the menu items that are here on the bar at the top, the toolbar buttons, all of this is created on the fly when the program starts. That means that you have a great ability, a really fantastic ability to redefine what menus you get and what keyboard shortcuts you have. So you could, in theory, if you really wanted to, reconfigure the entire user interface to do exactly what you wanted it to do, and it wouldn't really be that hard. There's really kind of two levels here, and I'll start with the first level, which is what if you just want to apply keyboard shortcuts or key bindings to particular menu items. Okay, so we have a File Options Edit Menus menu item, and now we're getting a little confusing, right? That'll allow you to edit those menus and add key bindings. So it's under File, Options, Edit Menus. And you have to realize that the way the program's set up, we've got different menus for different portions of the program. So each of our window types, for example, the Waveform Viewer, the Symbol Editor, so on and so forth, have these menus, and each of those menus is defined essentially in a file here. And you can go ahead and add, for example, if I wanted to save schematic as, if I wanted to add a keyboard shortcut to that, you can just click on this accelerator button, and it's waiting for you to type some keys to define a new keyboard shortcut for that. So say I did Control-Alt-S. So it says Alt-Control-S is now going to save the schematic as. So if you've got items, and the point here is if you have menus that you're using all the time and you're much more oriented towards keyboard shortcuts, this is a really great way to come in here and simply add menu items. Now if you remember, we talked about ReplayTraces. ReplayTraces doesn't have any keyboard shortcut and doesn't have any menu. So how would we use that? How would we define a shortcut key for something that doesn't have a menu? Well, you couldn't use that dialog. And okay, so here's someone just asked, how does this relate to a custom startup script? This is a great question. So so the answer to the person's question is you don't, if you're using a custom startup script, you're using this second part, which is essentially, here's a low-level way of doing it. So we have a def menu and def key. These are two primitive commands which define menus and keyboard shortcuts. So you could continue to use there's a startup script location for SIMPLIS, which is, I think it's here. So File, Options, Edit Startup Script. So when you would first start up the program, we run your startup script. And if it's empty, we just say, well, it's empty, no big deal. But this is where you can put special commands to configure your user interface. So for example, we could just create let's create a def key real quick. And I can tell you they're pretty simple. So def key is really simple. So let's use it for a real simple one. So it doesn't have to be all caps. I don't know why I did that. So let's assign the F4 key to ReplayTraces. Right? That's all it is. The syntax is here at this URL that's in this is all in the presentation material. But basically, I think I clicked on the wrong one. Sorry, def key is here. Basically, what the key was and the command. So if I go ahead and press OK on that, oh goodness, it does help when you actually type things correctly. When you press enter, it'll be a silent accept, but now if I press F4, I get the last curves that were generated. So if I shut down the program and I restart the program, that will no longer be there. So what you would need to do is you would need to, if you wanted to make this permanent, is you would take and copy this command into your startup script. That way every time the program starts, we would go ahead and execute your startup script and run that command. I don't know if that answers the question or not. Okay, here's a really good question. We're talking about Q. So one of the attendees wrote in, I define Q, query, to be like F7. F7 is our standard edit a component. Occasionally when playing with models and components, for instance, SIMPLIS redefines Q to place a component. Is there any way to prevent SIMPLIS from dynamically overwriting our customizations? Boy, at the moment I would say no, but I'll take that as an action to look into. We use Q for that whenever you make a symbol. For example, you're doing an ASCII model or editing a symbol. Q will place that symbol for you. And we do it just like this. We have a def key in one of the scripts. So I'll take a look into that, see if there's a way maybe to do something different there. I'll search out where we use Q. There's a couple places. Okay, any other user interface questions? I don't see anything else coming in. I'll just kind of make mention that the part selector, you have a part selector, etc., in a common window area. Sorry, that kind of looks like a statement. What's the question then? Can you? You have a part selector, common window. Okay, so I think the question is kind of around system widgets and main widgets. On my left-hand side of my screen, I've got the part selector, the command shell, and the file viewer. These three items are what we would call system widgets, or system windows. The rest of the screen is a main window, and that main window can be split, for example, with a graph. And you can move things onto, if you grab you can move this over here, for example. But you can't move a system window onto one of the main windows, whether it's split or straight across. And it's just kind of the way things work. I wish I could tell you there's a good reason, but there's just no way to make that work in the code. So I'm not quite sure if that answers the question or not. I don't see any response. So, all right, any other user interface questions? Okay. That being the case, let me go back to, I think where I was presenting last was part selector customization. I'll just, we won't spend too long on this. We're at the last 5 minutes of the webinar, but you can customize the entries that are in the part selector. And there's a GUI that will allow you to mess with the categories. So the categories are these top-level things like controlled sources. And there's another question that came in. Sorry for pausing there. So there is a way to do that. Here's the menu. You can also add individual devices to a category. And although that's not really supported by a GUI, there is a place to do it with the part selector. This is a link to the user manual which shows you how to do that. Okay, so I've got a couple questions here. Okay, so not quite. So I didn't quite answer the question. So we have combined the file view part selector into one sub window, meaning can you detach these? I think you can. And now once you detach a window, this window becomes its own window. So this is the part selector in its own window. And I did that with undock. So if I go back to my now undocked part selector, I can dock this to the main window, and it should remember where it was last located. I think you can also undock all. That undocked all part selectors, and there's only one of those. So what I can do is now dock those to the part selector and dock this to the part selector. And now I've got a window that is the part selector, the command shell, and the file view. And here you can mess around with these to do whatever you'd like. So I don't know if that answers the question or not. Okay, I don't see any other questions. Matt, is there any other questions that you've got that we need to handle?
None here.